sorry, this is an infinite dimensional vector space.
Correct.
So a trace is like an integral or a... What is this trace, I guess, is my next one.
So I'm imagining it in my head as you take a giant super infinite matrix and you just add the diagonal.
It's going to be 0 almost everywhere.
Which is, yeah, it's going to be 0 almost all the time.
Okay.
There's probably a much better way to define the trace, but it's not in my brain. Okay, so this is, why do we care about this? Question.
Will this like converge? Because in R0, that's why.
Yeah, that's.
Defined. Is that true?
That's why the trace is defined.
Because your
R0
yeah, exactly.
coefficients have high.
Yeah,
right. That's why we're restricting.
Convergent.
This doesn't work in general. So we're restricting where we can apply this.
It's convergent power series.
Okay, so the idea is that this is starting to come together. We've related to our character. Our character's gone to a better party. And we're looking at products over powers of p. And over here, we know that if we're summing powers of p over the type Mueller list, we can relate it to the trace of this map. And because we threw out all the 0 stuff and we're just dealing with stuff that's not equal to 0, we're eventually going to relate this kind of sum to a sum over the type Mueller lifts. And so then if we can understand this linear map, we can sort of understand all the action. That's sort of the strategy. Okay, I have one more line. So if G element of R0 has matrix A, it's a little weird to say this, but that's what Koblitz does. I'm going to stick with what he does. So then the determinant of 1 minus AT is a well-defined power series. It's going to have infinite radius of convergence. And it's in fact going to be equal to the p-adic exponential. If anybody's unfamiliar with this, if you got like a power series and all its coefficients are in Q, then you can sort of say, not how does this converge in C, but how does it converge in QP, and you get a different function. So this is equal to exp negative s equals 1 to infinity trace a to the s t to the s. Okay, so later we're going to sort of kick the zeta function around, and we're going to make it look like something like this, and then this looks like this, and then we're going to use our knowledge of this map and the trace to show that everything is cool. I'm going to take a break a second. Does anyone have any questions?
So A is an infinite matrix, right?
Yeah. Okay, so from before we had that q to the s ns prime is equal to q to the s minus 1 to the n plus the sum x bar in fq cross, sorry, fq to the s cross to the n plus 1 over epsilon to the trace of x naught f, and I'm going to just do x bar. So hopefully everybody remembers before. Okay, so we want to replace, we can just think of this thing as one big polynomial, and we're going to replace its coefficients by their type Mueller lifts, and we're going to get, I'm going to call it h. This is sum I equals 1 to capital N AI x to the wi. Once again, this is a multi-index. It has a bunch of degrees for a bunch of different variables. Okay, so now that I've got this, I'm going to rewrite this guy. This is going to be q to the s minus 1 to the n plus sum over x to the q to the s minus 1, yeah, q to the s minus 1 equals 1. Product of I equals 1 to the n. Theta. Wait, is this a theta? Theta, yeah. I'm sorry. I'm really bad at Greek letters. Okay. AI x to the wi times dot 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 theta AI p to the rs minus 1 x to the prs minus 1 wi. So what did we do here? We used that we had an additive character to split this sum up into a product, and since we are throwing out all the zero stuff, all our type Mueller lifts are in fact the roots of unity upstairs, and we're setting ourselves up to use this lemma. Is everybody with me? Okay. So, what do we got? Okay, so I'm going to define g of x bar to be the product I equals 1 to capital N, this thing, basically. Is everybody okay? So just drag the product upstairs, drag it down. But we only want to go to theta AI p to the r minus 1 x to the pr minus 1 wi. Okay, so at this point, we have q to the s ns prime is equal to q to the s minus 1 to the n plus the sum over the x to the q to the s minus 1 equals 1 of g of x times dot 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 g of x to the q to the s minus 1. Okay, and we can use the lemma, and then we get that this is just equal to q to the s minus 1 to the n plus qs minus 1 to the n plus 1 times the trace of psi q g to the s. Okay, we're almost done. Does anybody have any questions?
What is it, n plus 1?
So we picked up the x0. I believe it's the, yeah. So this is an n plus 1 tuple. Okay, so I'm going to rewrite this thing. I equals 0 to n, negative 1 to the I, n choose I, q to the s times n minus I minus 1 plus sum I equals 0 to n plus 1, negative 1 to the I, n plus 1, choose I, q to the s times n minus I times the trace. I'm just going to write psi if it's already with everyone to the s. And why is that true? So I think this is just expanding out these guys here. Okay. So at this point, we are basically done. We have that z prime of t is equal to, we can think of our exponential series over p, so we have sum s equals 1 to infinity n prime s t to the s over s.